Hello everybody, my name is Rishmita Brahmadevara. Today I am going to present my project Ghibli image classifier using deep learning. Nowadays it is going on trend where many are converting their images into a Ghibli portraits. Watching them in social media, it actually made me interested. So that is the reason I have chosen this project. And my main aim in the project is to achieve a high accuracy while keeping the model like lightweight and to classify them in a Ghibli themed portraits. So coming to the code, I have used libraries like Random, NumPy, Matplot, CV2, Torch, and Torch Vision. And the data set, I have chosen it from the online repository. So here in the data set, in the classes, we have defined real as 0 and the Ghibli as 1, and the formats of the image to convert from original to the Ghibli portrait will be PNG, JPG, and JPEG. So, uh, to load the real image, we have given in the class 0, and in the class 1, it loads the Ghibli image. And in the function, it defines the height and width of the image as well as the colors. So it have the multiple plots, so, like width, height, aspect ratio, and width versus the height. So all are defined here. And coming to the data augmentation, so once after the original image is transformed to the augmented image, there will be a slight changes in the colors and the sizes of the image, and it will choose the highest augmented one. So that will be the highest accurate image. So here it will resize the image. As I said, the height and width will be resized and also the colors. So it will load the image and it will transform from the basic one to the augmented one. So in the visualize effects of data augment, the original images and their augmented versions will be shown. So it's the original image, and once after it is converted, like it will be like a Ghibli portrait one. So, uh, yeah, when we compare the original ones and the augmented ones, the count of the pictures will be doubled actually. So, where it has the basic transformed ones and the augmented ones. So, if the original ones are around 1000, then the augmented ones will be around 2000. So, the count of the images will be doubled. And so when we come to visualization function, where it shows the train loss and the validation loss of the image when it is about to transform, and we will be giving the epochs. So here we will be giving certain number of epochs like 10, 15. So in that it will be having the highest accurate one, that is actually the Ghibli image, portrait image. So let me show you some of the outputs for this code. So here in the data set, we have given the real images of around 2500, and when we convert them into a Ghibli portraits one, we will be getting the 2500. So it means all the images which are given will be transformed. So here it shows the sizes. So all the sizes are in pixels. In the pictures which are mostly in the data set having the width of 400 by 50 and the height of 1000 by 25. And this will demonstrate us how the image width and height is distributed. And this is the distribution of aspect ratios like width and height. So it is from 0.4 to 25. Like most of it, like it will be like epochs will be in between 15, like 1 to 15. So it's 0.4 to 1.8. And these are the width versus height. So it's just in a pixel form. So once after the data visualization is done, the images are loaded correctly, and then it will be applied the transformed one, which will be like more appropriate to the original image. So these are the real images. So it will be like the normal image which we have taken in our cameras. So once after the transformation is done, so the Ghibli portraits will be in the form of animated ones. So these are the Ghibli portraits. So coming to the colors, so once after the portrait is done, like once after it is transformed, there is no change in the color. The most of the colors in the real image will be given in the same Ghibli portraits too. So if you see, these colors are like many colors we have in the real image: blue, white, orange, and you can see in the Ghibli portraits too, orange, green, white, cream, everything. Like we have multiple colors. So once after it is transformed, the according to the picture, the it will be getting the similar colors for the Ghibli portraits too. So here, once after the data augmentation is done, if you see, there will be slight differences in the sizes of the image and also the colors. So the original image, it looks like small and the colors are not that bright. So once after the transformation is done, you can see the size, it was a bit wider and the colors are like similar ones. Like there is no change in the colors. But once after it is augmented, you can see the change in colors too. So the most accurate one will be given in the augmented pictures. So if you see here, when we compare the original ones with the augmented ones, so here the real image count is 2,500 and the augmented ones is 5,000. So when you compare with the original one with the Ghibli portrait one, it is same. There is no change. But as I told you before, the process of conversion from the original one to the augmented one, the count of images will be doubled. So here it is 2,500 and then it is transformed to 5,000 where it is the augmented one. Okay, now, if you see here, these are the pictures which are pre-trained ones that allow us to make easy in transferring and which also improves the performance and also reduces the training time. Training time, it will be like most probably around 45 minutes to 1 hour. Um, like it depends on the epochs you have taken. So number of epochs increases, the time also increases in the training. So these are the epochs. So these are the training models actually. In the training models, we have the epochs. We have taken like 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For each epoch, there will be like train loss, train accuracy, validation loss, validation accuracy. And the validation accuracy will be increased or like decreased from one epoch to other epoch. If you see here in the epoch 1, it is 0.8905. And for the epoch 2, it is 0.9440. And epoch 3, it is 9470. And epoch 4, it is 0.9480. If you see, like, it is slightly increasing, and in the epoch 5, it was decreased. And again, in the epoch 6, it is increased. So, when it is going from one epoch to other epoch, the training and the evaluation will be done, and the according to the train laws and the train accuracy, validation laws, and validation accuracy there will be slight changes in the validation accuracy. So, which is having the highest validation accuracy? That is the most accurate one. The like that is the best one in comparative to the other epochs. So, if you see here, the final one is with 0.9615, but also you can see here for the epoch 8, it is 0.9620. So it means epoch 8 is the most accurate one. So once after the transformation is done and the training is done, the most accurate one will be chosen as the Ghibli portrait one. So in the 10 epochs, we have eighth one as the most accurate one. So here you can see the graph of the training and validation loss and training and validation accuracy. So if you see in the loss, there is a very little loss in the end. So if it is started with 0.275 and it is ended with around 0.11. So it was very less loss. And coming to the accuracy, in the initial, it is like 0.88. So the epochs are going on increasing. Like the train accuracy is increasing from one epoch to other epoch, and in the end, it reached to 0.96. I guess it is more than 0.96. So this is the one, 0.9615. This is the end one. So here it is 0.981. 9620 actually. So this is the most accurate one. So as it shows 0.9620 is the best accurate one. The Ghibli portrait chosen for the picture will be like Epoch 8. So this is my project. Thank you.